Ready? Friends, welcome to the online live lecture on the risk and reliability of offshore structures course. This course actually is a rerun course based upon the demand from the industry and the students and academia and faculty friends all over the world. The most important feature which people used to ask me by email as well as discussion forum when this course was first offered last year in NPTEL portal at IIT Madras is why risk and reliability are combined and what is the speciality of this when applied to offshore structures. So the first question of primary interest would be why risk and reliability are combined. The second question is, when applied to offshore structures, what would be its special features? The whole course, friends, is circumscribed explaining these two objectives. Many participants who are registering for this course, who have undergone about 7 weeks of lectures, who also attempted to submit the tutorials, will be curious to know how risk and reliability will be combined and what would be its application when come to offshore structures. To answer this question, let us ask a fundamental question to ourselves. What is actually reliability? Reliability actually is a positive phase of failure. What do you mean by a positive phase of failure? Let us take an example. There is a class of students which contain about, let's say, 100 numbers. They are all appearing for an exam offered by a faculty, and it is compulsory so that all 100 students will have to appear for the exam. Once the exam is conducted, then the papers are evaluated, then results are declared. It's a very common process which we all know. Once the results are declared, then marks or grades are awarded on a relative basis. Now, there are many ways of expressing this result. One way of expressing is the faculty or the teacher can state that about 20% of the class have secured fail grade. Let's say he declares like this. This is essentially the fact. But to keep the entire class in a happy mood, faculty can also say 80% of the class have passed the course. Friends, please look at both these statements. Both are expressing the same fact. 20% failed, 80% passed. The first one is related to safety. The second one is related to reliability. Safety is always expressed as a mode of failure. If failure is ensured, there is no safety. So, safety and failure are expressed as the contrary. So, in structures, we generally express what is called probability of failure. Which is expressed as PF. So reliability is essentially 1 minus probability of failure. So actually, it is the positive phase of the fact of failure of structures. Now, friends, the next question which can come to mind is when structures are designed, they are designed according to certain codal provisions. If the codal provisions are strictly met and there is a strict compliance to the code, then how structures can fail? How structures can fail? That's a very interesting question because structures are designed to meet the codal provisions which are very stringent so that they do not permit failure of structures. If structures cannot fail at all by any design process, then reliability or reliability study has no meaning. If they don't fail, then there is no probability of failure. When there is no probability of failure, there is no reliability. So the foremost thing which comes to mind for understanding is how structures can fail. Let us divide this question into two separate parts. Part 1, structures. Part 2, how they fail. The moment I say structures, I am not talking about ordinary class of structures. They are special type of structures. What is the speciality about structures? We are talking about here offshore structures. Offshore structures are definitely different from conventional structures in many ways. I can give you certain examples for you to realize. If you look at the course content which we have offered so far, you would have also understood and realized that in the application part, of reliability, we expressed the speciality of offshore structures. Let me put as a summary here. Offshore structures are novel. They are strategically important. What do you mean by strategically very important? Because they play into the economic consideration of a country, because oil and gas production is one of the important key factor which controls the economy of any rising or any developing nation. Strictly, it is true to apply to India and any developing countries. So they are strategically very important. Number 3, they are one of the most expensive structures that can be constructed. 4, there's a heavy investment, what we call capex, There's a heavy capital investment in these kind of structures. Now, friends, let us understand these 4 points and ask a question. Any object or any material or any system which attracts heavy investment will always be at risk. Because if the investment doesn't yield the return, in financial language, we call this as return on investment, which is expressed as ROI. When the return on investment is not guaranteed, then the investment what you made is at risk. So now, friends, offshore structures are at risk because of the investment. That is the first factor. The second factor is it should yield me the necessary quantity of oil and gas. Oil and gas actually are natural reserves. Nobody actually can trace completely how much content of oil and gas is present in any specific belt, because it is due to the geographical movement, it keeps on shifting from one plane to another region. So when you do not know exactly the quantity of oil and gas reserve present in a specific belt, you invest on constructing a system to explore this oil and gas, and if you do not get the investment back in terms of production of oil and gas, your capital investment is at high risk. Whenever there is a risk involved, there is always a concern of safety. Here we talk about 2 kinds of safety. One is financial or material safety. Whatever you have invested, are you going to get this back? Second is human safety. Now, why this can be a very important concern in offshore structures? Let's ask a question. Why human safety is a concern? Friends, there are many parallel courses offered in NPTEL at IIT Madras with this as a special focus. I can name a few of them which I want you to really go through, which is freely available in the NPTEL website. One will be ocean structures and materials. Offered again at IIT Madras. Other would be dynamics of offshore structures, offered again at IIT Madras. The third course could be computer methods of analysis of offshore structures. Which is again offered at IIT Madras. The fourth could be health, safety, and environmental practices of oil and gas industry, which is again offered at IIT Madras. I request you to go through these courses in parallel for your self-learning and get importance to answer this specific question, why human safety is a concern in offshore structures. However, for our interest, let me summarize. Human safety is important because offshore structures operate in a hostile environment. That's number one. Hostile environment means they have no direct connection to land. Okay, they are operating in sea to land. That's why they are called offshore structures. Offshore structures. They are off the shore. That's why they are offshore structures. Since there is no direct connection to the land, people working on board in offshore structures should be saved, number one. Number two, the technical manpower is very precious. It's very important. People who work on offshore industry or offshore platforms essentially are highly skilled. So the man hours, the training, the salary, the dedication, what these set of people put in the platform during exploration and production is phenomenal. So it is important that we should protect their safety. The third issue would be offshore industry is a multi-capital investment. What do you mean by multi-capital investment? No single company invests on these kind of structural systems. It is multinational. It is multi-corporate who invest money on these kinds of platforms. So now, when there's a global investment involved, the risk is much higher. So when the risk is much higher, then the following question is, what would be the chance of its failure? So that's a very first question any investor would ask. This is what we express as probability of failure. Because failure is not certain. It's not certain. I can explain this because if failure is certain, there will be no investment. So failure is not meant to become certain. Failure is accidental. Therefore, there's a probability of failure. The moment we have any failure, any event which is not certain, we always express this in probabilistic terms. So friends, those who are online with me now at this moment, I urge you to think it over for a few minutes and ask me any question or doubt if you have, or any views you can share about your experience on working on offshore industry. That would be helpful for other people who are online to actually share your views at this moment. So any structural system whose failure is not certain can be expressed in probabilistic terms. So therefore, friends, since reliability is 1 minus probability of failure, reliability is also expressed in probabilistic terms. So that's the important reason why reliability is always expressed in terms of probability. Now, to build up a basis for understanding probability, we have expressed few lectures, like in week 1, we spoke about introduction to reliability. There we said why reliability is important, how reliability and risk are connected, what is the difference between the terms risk, reliability, and safety. Friends, to recollect what we have discussed in the previous lectures of week 1, risk actually is a product of probability of failure and the consequences. The moment I say consequences, one is more importantly interested in knowing what would be the financial consequences. So the moment I say risk, I can say that risk is an extension of reliability. How can we say this? Because reliability stops at assessment of failure. Okay? Whereas risk takes it forward to check its consequences. Therefore, risk and reliability combined together will be a very useful exercise for offshore engineers. If you have any friends who are online joining me at this moment, so they can always share their views as far as this statement is concerned. The moment we talk about probability and statistics, we need to explain what would be the basic rules of probability. What rules are we following? This is what we expressed in week 2. We dealt with different rules of probability. We derived the basic Bayes theorem, Bayesian's expression, then total probability theorem, which are all useful to express probability of failure of any structural system. Now, when we talk about offshore structures, they have one more speciality which is highly complicated. Offshore structures are attracted by different environmental loads. I can state a few examples of these loads. One, loads can arise from waves. They can also arise from wind. They can arise due to current. They can arise due to ice loads. They can also arise due to earthquake loads. They can be also due to shock and impact. They can also be due to marine growth. They can also be due to dead load and live loads. You see, friends, those who have engineering background will appreciate one important statement which I'm going to make now. Look at the combination of these forces. You can say now and accept that offshore structures are possibly one of the high class of structures which has such a wide combination of forces. It's very rare to find a structural system which is exposed to a large combination of environmental loads as you see on the screen now. Now, offshore structures are by that way novel. Okay. Now, what is the difficulty when these combination of forces act on a system? Let us take, for example, the wave force. For example, let us take the wave force or wave loads. Usually, wave loads are described by two parameters. One is the wave height, which is usually expressed as h or wh. Other is wave period, which is usually expressed as t. Sometimes, in a given sea state, waves can be simulated by an ideal sinusoidal wave or superposition of n number of such waves. So each wave will have a different wave height, will have a different period. Okay. Now, put together of these, I can express them as a random phenomenon, which is going to give me the time and the wave elevation. Eta is a function of time and space. The moment I have a variable which is sea surface elevation, which varies with space and time, then I can express the combination of this using a random variable. Therefore, in week 3, we discussed more basis on random variables. What are the variety of random variables involved? How are they handled? How are they cross-correlated? And what is autocorrelation? How random variables can be expressed in terms of a spectrum. The moment I talk about a spectrum, wave loads can be expressed by variety of spectra in offshore engineering. The famous one is the Pearson-Moskowitz spectrum. You can also have Harris spectrum and so on and so forth, which you will find in a very interesting book, which is authored by me. Reliability of offshore structures. Published by CRC Press. Friends, IIT Madras NPTEL administration has a very interesting focus. The course contents, which are video lecture, are also published as a PDF file in open domain. Further, they are also published in terms of textbooks. You please visit NPTEL site of IIT Madras. You will find list of books published under NPTEL label. You will find this book appearing there in one of the lists as reliability of offshore structures. You can also have a free sample of one of the chapters. To view at this book, please email to me at drsekaran@iatm.ac.in. I'll try to send a free copy in terms of a sample of one of the chapters. You can go through them and get educated and then add your comments to that. So coming back to random variables. Random variables, as expressed in week 3 lectures, have high complexity. They have a large spectra of variation. Friends, if you have any doubt or difficulty at this moment, you want to add a point, you can always stop me, share your views immediately so that I can also address that concern online at this moment. Let's say it has got a large spectra of variation and high complexity. Therefore, it is important to understand how they are handled in reliability analysis. So in week 4, friends, we discussed about various levels of reliability. The moment we talked about various levels of reliability, we started with a simple first order reliability model, first order second moment model, advanced FOSM model, etc., which all tells you how the random variables are handled mathematically. In short, this is what these models actually do. Now the question comes, what are these variables? These variables are of two types. One arise from the structure, one arise from the environmental loads. Let's give an example. Let's say environmental loads as wave height, wave period, wave direction, current presence, etc., which can vary from time to time. Therefore, they are random variables. Now, the structural properties like strength, material degradation, etc., can also vary from aging. Further, offshore structures are also under severe corrosion. So this will enable a degradation which is much faster, which will reduce the strength. Now friends, there are two set of variables. One addresses the strength, other addresses the loads. Now, when the strength exceeds the load, we can say it is safe. But when the strength is lower than the load, then it is unsafe. So in reliability study, we are trying to find out what is the probability that strength is lower than the load. Or reliability index beta is actually the difference of this. As a function. Now these two can be expressed in different models. The simplest form is a normal variate model, which is statistically popular, whose spectrum or the governing equation is known. The probability density function is well established, and you have statistical tables which can express the probability density function and its probability of failure in terms of a variable readily in mathematics books. Higher order models will also discuss this. For example, Haushofer-Lin model is one amongst them, which we discussed. Haushofer-Lin model aims to find out the design point for a given normal variate, which is the minimum most distance for a tangent point, and this is the design point, and this is actually the distance of the point from the origin, which is the minimum. So the objective is to find out the design point, which gives me the reliability index directly by iteration. So these are all expressed in week 4 lectures. As we move ahead, in week 5 and 6, we talked about system reliability. We know, friends, system is an assembly of members. The moment I assemble, I will have links. Sometimes they are arranged or assembled in series. Sometimes they are assembled in parallel. So we have seen how a weak link in series system and parallel system can cause a failure. If they are combined, then how failure can be predicted. We express this in detail in week 5 and 6 lectures. So furthermore, friends, in the coming modules, we are also handling application problems. One of the interesting application problem which you can look forward is fatigue reliability. A detailed experiment studies have been conducted in IIT Madras. investigations have been carried out. At IIT Madras, which has been put as a part of the lecture. So fatigue reliability is one important area where offshore structures are examined as a mandatory part under the given codal guidelines of APARP. In the further module, we went ahead and planning to discuss risk, hazard, and reliability. So friends, you will enjoy the content of the course is widely spread from understanding the basics of reliability, the basis of mathematical foundation for performing reliability analysis, methods of reliability, levels of reliability, system reliability, risk and safety, then hazard and reliability as applied to offshore structures. Friends, you will appreciate that the contents have been widespread for a variety of topics which can facilitate easy learning for a background with engineering discipline. Now, the most important question which can arise from the viewers or the registered participants would be, what would be the pattern of the examination? It is very interesting and important to know it is going to be an offline exam. The question paper will have both theoretical questions and numerical examples. You will not be allowed to use any code, but you can use calculators. Please understand, when this course was floated earlier, about 4,500 odd people have registered for this course, and a variety of people got highly benefited from this course. And most importantly, there may be faculty, friends, and colleagues who will be registering for this course. Let me tell you, reliability of structural systems has become a mandatory condition for structural systems under high risk. So every engineering university have been requested to offer a course on reliability. Not necessarily offshore structures, reliability of structures. So friends, those who are online at this moment, if you have encountered any similar experience of teaching this course or framing a syllabus, you can always try to share your views. I think there is a question. Let's try to address this issue. Share it. So Shruti, there is actually a question asked by you, why fatigue reliability is important? That's a very interesting question. Why fatigue reliability is important? I'll explain this with a simple example. Let's take an offshore structural system which is completely compliant in nature and anchored to the seabed using T-curves. I am talking about a specific example of a tension leg platform. Let's see what is a tension leg platform quickly for our understanding. If this is my water level, I am drawing the elevation. This is my water depth expressed in small d. This is what I call as draft, dr. Okay, these are nothing but cables. Let me explain the system. The system is containing a superstructure. The superstructure will have different set of operations like crane loads, then equipments, derricks, all will impose a live load. So the system will have a weight which is acting downward. Now when the system is immersed, there is a submerged volume of the material and member which will also offer a buoyancy force upward. Now the system is designed in such a manner that the buoyancy will exceed the weight by a large amount. When this happens, the system will start floating. When the system starts floating, I cannot conduct any operation. Therefore, I have to hold the system down, hold down in position. I use tethers for doing that. So tethers will be all in tension. That's why this is called tension leg platform. Having said this, let us say under the wave load, the system starts moving to the right. You can see here, compared to the green picture, the red picture has change in length in the tether. I call this as delta T0. This delta T0 compared to T0 will have some change in length. This change in length will induce additional strain and additional stress. Depending upon the cross-section area, one can work out the load which is axial on this member. When this load history varies with time, it has different cycles of variation. When there is a cycle of variation, even though the amplitude is low, even though the amplitude of variation is low, but a large cycle is varying. Large cycle of variation, then you understand fatigue becomes important. So it is necessary that we must study fatigue reliability in offshore structures. I hope I have explained the doubt what you had. If it is still not clear, please share your views again. So friends, we are coming to the end of this live lecture. My recommendations to the viewers will be the following, which I call as summary. Number one, please share your experience and knowledge through the discussion forum of NPTEL, which is under the label Ask a Question. Because all other participants can also be experienced. Number two, it is a very good learning exercise for me, learning exercise for myself to improve my level of knowledge from the industrial feedback what you can give me. Further, reliability as a course is generally a difficult level course. It is offered in master's level in engineering. I want to make it simple, easy, and affordable technically to all engineering students. So that is the motivation why IIT Madras at NPTEL is offering this particular course for the benefit of the viewers. I sincerely thank the NPTEL administration for giving this opportunity for a live class. There's a big team working behind this course, my teaching assistants, research assistants, studio directors, and other editing experts who are all online with me at this moment. I thank all of them sincerely. And I think by spreading the discussion of this idea and exchanging views from the viewers like you online, we are all mutually benefited. Thank you very much and best of luck. Bye.